Okay, so this is your Python lab, SBLC lab, and in the last lab, we had a discussion on implementation of inheritance, which is the first program of your fourth experiment. So here we implemented the inheritance where we had one base class called the person, then we had another class which is a derived class which is student derived from person. So likewise, you can have one more class, say employee derived from person, because a student is a person and so employee is also a person. Okay, so whatever things you have in the person, for example, name, address, mobile number, photo, identity, and so on. So all those things you can reuse in student, you can reuse in employee, and so on. So there we are making use of inheritance. Then we have seen how to define the constructors in the base class and in the derived class, and how to make use of a constructor of the base class in the derived class, or how to call the constructor of a base class in a derived class constructor. So this is one of the important thing when you deal with inheritance in Python. So once that is done, then you can make use of the objects of the derived class to have the features, to have the new features of the derived class and the old features of the base class. So you have the combination of the two things. So that's what we have done into this program. Now the next part of this experiment is the implementation of inheritance. And then we have the fifth experiment, which is your implementation of advanced data structures in Python, like stack, queue, and a linked list. So what we'll be doing, we'll be starting with the fifth experiment. So first we'll be completing that part, and then if the time permits, we'll come back and we'll complete the second program of the fourth experiment. So in the fifth experiment, uh, we can do it using a single program into which you have stack, queue, and linked list, or else you can have two different programs, one program for stack and queue, and another program for linked list. So it's up to us how do we implement it. So let's start the implementation of the fifth one. So in my programs directory itself, I go for the new program exp5.py. So this is the implementation of stack, queue, and linked. So first we'll be implementing the stack. So we'll be implementing the stack using list. And then we'll be implementing the queue. And there are two possibilities. We can implement the queue using list, or we can make use of a library for the queue, which is called DQ, a class which is available. So first, let's start the implementation of a stack. Now, uh, you can have your own push function, pop function, and so on, and even the display function for displaying the content of the stack. And or in your driver code, that is your main method or the main function, you can actually make use of the list functions or the list methods to perform all these operations. So we have the two possibilities. So we can go with either of the possibility. I repeat, we had a discussion on this in the last theory class or the theory session. So I want you people to vote it out that which kind of implementation you want. You want me to make use of the list function directly from the main method, from the main function, or you want to write our own push function and pop function, and then inside those functions we'll be calling the same list functions, that is append and pop. So which way you want to implement? So let me know fast. Come on. One, please let me know. You can post your choice into the chat box. You want to write the stack functions, or you want to simply call the list function from the main method, from the main function. Or there is one more possibility. You can encapsulate all those stuff inside a class. So you can have a class for a stack, you can have a class for a queue, then you can have a class for a linked list. So what way you want to implement it? Chalo, please let me know. Class. Farhan says class. Any other student? Class or simply functions or no class, no function and directly into the main method. All are saying class. Okay. So let's do it using class. So let's define the class for the stack. First we'll go for the constructor and what to initialize into a class stack. Shall be having a data of a stack now. So let me call self.data equals to something and let me pass it from here. If nothing is passed, so it is none. Okay, so we got this. Then we will be having the push function self and then the data you want to push, obviously. So let me call it D. And then inside this, I would be saying self dot data. This data is expected to be a list. I repeat, this data is expected to be a list. Okay, so here the D is expected to be a list, and here a data D is expected to be a element of a list. So here what we'll be doing self dot data dot append. So we are appending into the list, and what we are appending this D. And then let me have a pop method for it self, and this would be returning self dot data dot oh, there's some problem, or there could be a problem because this pop and this pop they may not resolve. This is a pop of the list class, and this pop we are defining for the stack class. So let's pop s. So it is pop stack, or let me call it pops. And then I would like to display my stack. So here I can say print. No. If self dot data, if there is nothing in my self dot data, so if self dot data equals none, then I would say my stack is empty. Else we want to display it element by element. So we would say stack content and then I need to display it for I in range. I need to get the length of my list. So self dot data minus 1, and I would like to go up to 0. So I would say again minus 1, and my step value should be minus 1. I'm starting from the last element, so it is something like topmost element. I want to display the topmost element, then the next topmost, and so on. And I want to go up to, I want to come up to the 0th element. So that's why this range would be like this. And I would be simply saying print self dot data of I. Yes. So I think yes, your class is done. So now let me have main method, and let's have an object of a stack class into this. So my stack is st, which is an object of the stack, and I want to pass a list and some elements 10, 20, 30. Let's see how does it goes. Then st dot display. Then if my module name is then I would be calling my main method. Okay, let's see how does it goes now. What we are doing, we are creating a stack object and we are trying to display that stack. So let's see whether the stack is getting created or not. We are getting some syntax error. Self.data.append. Wow, why this colon? Okay, so your stack got created and the content of the stack is 30, 20, 10. Okay, and suppose I go for one more object of a stack and I say st1 equals to empty stack. I don't pass anything. And then I display st1. Okay, so the first stack content is this, and then the second stack is empty. So far, so good. Now let's check for the push and the pops. So let me push on my st1. Oh, before, okay, it is empty now, and st1 dot push, and I would like to push say 50, and then I would like to display it st1 dot display. None type object has no attribute append. So the problem is what when there is nothing. So a list is not getting created over here. So let me say it self dot data equals to an object of a list class. Self dot data dot append. Uh, I need to do one thing over here. If my D is none, then I would be doing this. I would be making it an object of a list because I need to do it. Else, else we will be copying it. Okay, let's try this way. Okay, now it is getting that. What's happening that when it is none, when you do not have anything, when you create an empty stack like this, so that time here the none comes, and when that none goes into our data, so data doesn't remains a list. It is of none type. So if D is none, we will make this data as an object of a list class. And if it is not none, so we are passing a list over here. So since we are passing a list, so that time this would become a list. Okay. So that is the check. And I think for a none, you need not have to explicitly check like this. For example, let me simply say D or not D. Not D. Let it be none. Let it be getting explicitly compared to none. Or you can do the reverse of it, that plot data equals to D, else self plot data equals to list. Okay. So either way you can do, but now here you can see that we are getting the things done. And suppose I push one more data element, say 60. So 60 now should come on top of 50. 60 is coming on top of 50. Why we are getting stack content twice? Okay. So now instead of none, I need to check for the length of my list. If the length of my list is 0, then I would say my list is empty. Yes. Okay, so we are implementing a stack using list, and we are implementing a stack as a class. So now we have implemented a push, we have implemented pops. Let me check for pop. So after this display, we would say st1 dot pops, and let's print it. Okay, so the popped element is 60. Here you can see, and the stack content is 50. I did not display here anything, so I can say popped data is so the pop data is 60. Here you can see because the stack content was 60 and then 50. So 60 and then the stack content is 50. And you can put some sort of check point over here. What I mean to say that if the stack is empty and you are trying to pop, so it will throw an exception. So you need to check for that. So it is as good as checking for the list if the length of a list is more than zero. So there is something into the list to be popped. And if your list is empty, if your stack is empty, that means your data length is zero. So you can say that the stack is already empty. Okay. Or what can I do? I can have one function for it. So for example, we can have one function to check def is empty. Is empty self, and we'll say if the length of my self dot data equals 0. So in this case, I would return is empty. So I would return true. And here I would return false. So this is empty. So here instead of this, I can check for only is empty. If is empty, why it is saying like this? Oh, sorry. Self dot is empty. Okay, so stack is empty. You are getting a message. So here also before popping, I can check if not self dot is empty, then only pop, or then only return this. Else you can say there would be, else I can say return, no. वही last time जैसे problem. So I can say so. Let's reverse it. If empty, then return this. Else return this. stack empty, then popping. So 60 is popped, then stack content 50, and then we do one more popping. So stack content 50, stack content 60, 50. What do we have displayed? Instead of not, I can make use of not keyword. Thanks for that. So stack content 50 and then 50 is also popped. So then the string stack is empty. So after displaying that, okay, fine. Because here I should do this. Popping 50 and then our stack is empty. Okay, so this is the implementation of stack. Now, if you want, you can add on few more things into this. And I stop the stack implementation because more than the required things are implemented into a stack. Now, let's implement a queue. Now, what is important over here to understand is two important things. To implement the push functionality of stack, we are making use of the append method of a list class. Please see there carefully. We are making use of append method of a list class. Likewise, to pop or to implement the pop functionality of a stack, we are making use of a pop method of a list class. We are making use of pop method of a list class. Why? Because in stack, the data is inserted and deleted from the same end. So in stack, you have only one end open. Okay. So from this end only, your data is inserted and your data is removed. So the data is appended from this end and then the data is popped from the same end. Okay. But when you talk about queue, so you have two ends open. So data is inserted from one end, but it is removed from another end. So whatever is inserted first, that is removed first. First in, first out in a queue. But in a stack, we have LIFO structure, last in, first out. Okay. So when you implement a queue, you can very well make use of a list for the implementation of queue. And for inserting a data into the queue, again, you can make use of the same append method of a list class. And for deleting a data from a queue, we can make use of a pop method. But the pop method by default deletes the data from the end. The last element is deleted. So what we can do, we can pass on a index value of the element to be popped. So if you pass the index value of the first element, so always the first element will be removed from your list or from your queue. So you are inserting a data with the help of append method, but you are removing the data with the help of pop method by specifying a index value. So you need to always delete the first element, and the first element always has an index value of 0. So if I pass an index value of 0, so that will delete the first element. So this is how we can implement a queue using list. But when you implement a queue using list, what happens that your pop method would be deleting the first element of the list. When it deletes the first element of the list, all the elements from the second element till the last elements, all the elements are left shifted by one position. all the elements are left shifted by one position. Because from implementation point of view, a list is implemented as a dynamic array. I repeat, in Python, list is implemented as a dynamic array. Okay. Now, since it is implemented as a dynamic array, if you delete anything from between, or if you are deleting something from this left end, so you need to right shift all the elements by one position. If you delete anything from the right end, from the right side, you need not have to shift anything. Okay, because your data structure is going this way. So if it shrinks this way, so there won't be any problem. But if the data structure is of this size and if it is shrinking from this side, so your all elements should be right shifted by one position left, because your base address would remain same. I repeat, your base address would remain same. Okay, so it is implemented in the form of dynamic arrays. So when you pop a element which is at the zeroth index, so all the elements to the right side of this zeroth element have to be left shifted by one position. Now this is a costly process. This takes time. So that deletion doesn't take time, but this shifting takes a lot of time. The shifting takes a lot of time. That's why it is said that implementing a queue using list is costly in terms of computation time. Implementing a queue using list is costly in terms of computation time. So what is done to avoid this issue or this problem? In Python, we have, sorry, from collections, you can import DQ or DEC. So DQ, double-ended queue, you can also read it as DEC. So DQ is a class. It is a class which is available from a module collection. So collections is a module, and into this collections module, you have a class DQ. So now you can make use of a DQ object, and then we can directly make use of the functions associated with the DQ class or the methods available with the DQ class. And the methods are same: append, and then you have pop, and then you have one more method called pop left. Okay, so what can be done, instead of having a class for a stack like this, I can directly have a queue for it. Acha, you can put all this into your loop, into your menu. So I expect you that when you complete this program, you will be making those changes. So you'll be creating a menu where you'll be having first option as a stack, then queue, and then link list. Okay. So into your stack option, you'll be doing all the stack operations. Then into your queue option, you'll be doing all the queue operations, and into the link list option, you'll be doing all your linked list related operations. So I can go for a queue equals to my DQ object, and to this DQ I would be sending a list. So say 10 comma 20 comma 30. So this becomes my queue of three elements, and to display this I can simply print it. So print a queue, or I can even iterate into my queue. So your queue is DQD30. If you want to iterate into it, you can iterate into it. And then if you want to add anything into your queue, so queue dot append, and you can simply add the element. For example, 40 I want to add, so I'm adding 40. And then after this, again, I want to display my queue. Then I want to delete something from my queue, so I would say print, and here deleting, and then I say q dot pop left. This is the method which you need to use because now we need to pop from left. This is a double-ended queue, so you can pop from right side also, you can pop from left side also. Okay, double-ended queue is what? A queue into which the data can be inserted from either end and the data can be deleted from either end. You can insert the data from the left side or the right side. You can delete the data from the left side or the right side. So here is our original queue with three elements 10, 20, 30. Then we have appended or we have inserted one more element 40 into our queue. So queue is 10, 20, 30, 40. Then we have removed one element from the queue. It is FIFO, first in, first out. So 10 should be removed. So deleting 10. So 10 has been deleted. And then the queue content is 20, 30, 40. Okay. So this is how you can keep on deleting the data, and this is how you can insert the data into the queue and you can maintain a queue. So what we are doing, we are we are importing a class DQ, and then we are simply creating an object of a DQ, and then we are appending into the queue, and then we are deleting from the queue with the help of this simple methods. So you can again have your own class for a queue, and into that class you can make use of all these methods to implement the methods of a queue or the insert and delete functions of a queue. So it's up to you how do you want to implement it. Now the last thing is about your linked list. Okay, so this is a queue using DQ. Then you have linked list. Now linked list can also be implemented with the help of class, and it's better to implement it using class only. So what we'll be doing, let's have its implementation. Let me have a class. Now we know that a linked list is a dynamic data structure which is a collection of nodes, and these nodes are interconnected. And the node has two parts, a data part and the pointer part, or the reference part, or the next part. Okay. So let's define a class for the node. So I would be saying class node, and then into a node we'll be having two things, the data part. Let me pass something into this. Comma D, comma N. And the next pointer part or the next reference part equals to N. And let me make this as none. This can be a problem for us. Then we have a node. This is something like your node structure, the way we implement it in C programming language. So this class is some form of that node structure where you have two things, the data part and the pointer part or the next part. And then we can have a linked list class. Now into this linked list class, what this would be having, this would be having a header. That's all. So self dot head equals to h, and then I need to have some functions related to the linked list. For example, we will be inserting a node into the list. We shall be deleting a node. We shall be displaying the linked list. So let's start with insert. I would like to insert so self comma and the data which I want to insert. So let me call it D. And then self, I need to have one new node over here. Okay. So let me call it new node equals to a node, and there I need to pass my data D, and I don't pass anything. So next part is null. So new node has been created, and then I would be checking for my head pointer. If my head is none, if self dot head is none, then I would be saying head equals to this new node. Okay, if that is not the case, else then I need to traverse this node, traverse this linked list. So I would be saying temp equals to self dot head, and then I would say while temp dot next not equals to none, temp equals to temp dot next. And once it goes to the last node, then we will be seeing temp dot next equals to this new node. And this is how I expect that insertion would be done. Now let's write a display function to traverse our linked list. If self dot head equals none, then we would say list is empty. Linked list is empty. Else I need to traverse a list, so temp equals to self. I can take up this code. Temp dot data, and here I would say print linked list contents. Okay, so I expect it should work except for some none values. So let's implement it. Let's use it. So here I would say L equals to my linked list, and I do not pass anything. And then I want to display it else dot L dot display. Let's see. Where it is missing one required argument. Oh, I did not make it none. So yes, it says linked list is empty. So far it's fine. And now let's have some content into my linked list. So I would say L dot insert. Now let's see whether this insert works. So I insert one data element. It still says linked list is empty. L dot insert and into the insert self and D. Then new node equals to node of D. Okay, then if self dot head is none, so head equals to, this is the case, it is none. So head equals to new node. Yes, fine. L dot insert. I want to insert this 10. Wow. So what happens when it goes into the insert? That is self and then new node. Interesting, it is not going into this. Oh, it should be self dot head. Funny mistakes. Thanks for the marking that out. Wow. English is still empty. Come on. Self dot head equals to new node. This is fine now. Okay, it is going there, but it is not setting it. Self dot head equals to new node, and now new node equals to node of D, and for this self dot data equals to D, and self dot next equals to N, which is none, but the data part is D, this D. So this should be happening. Let me display here the address. Uh, this is an object over here, and let me say self dot head. Wow, same object, but still it is creating a problem. So here it is getting done. No issue about that. There is something into the display. Self dot head equals none. Linked list is empty, and else m equals to self dot head. What is getting inside this? Is an object. Okay, we are getting English content, but there is no content. ये कब हुआ? It is getting into this. Fine, it is getting into that, but is not able to print anything. Okay. 10 is inserted, self equal, temp equals to self dot head. While temp not equals to none, or temp not none. Okay, you got 10. So this is how your English is now working. And instead of not equals to, I can go for the simply not none. Hmm. Fine. So this is how your English is working now. You got two methods in your English class, the insert method and the display method. And we have inserted only one node. You need to check for the addition of few more nodes. I go for 20 and then I go for 30 and then I want to display it again. So yes, your 10 is the first node, 20 is the second node, and then 30 is the third node. Okay, so your insert operation is working properly, your display is working properly. Now you can add a remove method or the delete method into this, wherein you can delete the last node. So this is how you can implement a linked list in Python with the help of your own class. Okay. Only the point is that you need to remember that you are going to create a node which will be having the two parts, the data part and the next part. The next part would be pointing to the next node. And if it is the last node, then it would be pointing to none. So that you need to keep in mind. Any query? Any question from your side? Okay, thank you. I stop the recording.